Hello everyone. Today I am going to introduce you an exciting technology called deep learning. You know, a simple personal computer can create a wonderful virtual world. A supercomputer can regenerate the entire galaxy. The mobile phone that you have in your hands is more capable of doing things than a supercomputer that was introduced 2 decades ago. But until recently, if we ask a computer to identify a bird in a picture, it will stumble, which will be easily done by a small boy. But now, thanks to GPUs and vast amount of data, the recent neural network algorithms have revolutionized the concept of computing. That revolution is called as deep learning. You know, deep learning has got many exciting applications. It can easily identify a cancerous cell in a picture. It can convert text into speech. It can convert speech in one language to other language and many more. So, the present day supercomputers are much better than human beings. Also, you might wonder, what is the meaning of deep in the term deep learning? Deep means layered representation of data. So, that's what deep in the deep learning. You will learn more about deep learning, in subsequent slides. So there are three related terms for deep learning. One is artificial intelligence, machine learning and deep learning. So ranging from 1950s to 2010s. So artificial intelligence algorithms try to mimic the human behavior based on something called symbolic artificial intelligence. So here, according to symbolic AI, it's a way of representing the knowledge of human beings about objects in a declarative way, such as by using facts and then rules. But symbolic AI were unable to solve complex problems such as image classification and others. So that's where machine learning emerged. And if you just ask me to define what is machine learning, now you need to compare your machine learning against classical programming languages and traditional programs. So in a traditional programming, you are inputting the rules, that is set of steps, along with the input data to the program that you create. So that the program that you create using languages such as C, C++, Java will produce answers or outputs. In contrast, your machine learning models require data and answers as inputs, and it will produce rules. We can call it like programs. So here data, it could be any set of data. It could be images, audio, video and so on, and the answers are the outputs for each sample of your data or data set, and your machine learning models that you are going to use will create rules. The rules that are created can be used for prediction. So your prediction, it could be recommendations or it could be classifications and so on. So that's the difference between machine learning and other general traditional programming languages. And then coming to deep learning. So deep learning is a way of representing your input data into hierarchy of layers called as hidden layers. So as an advanced concept of neural networks, where you create input layer and output layer, and in addition to these two layers you also create layer of hidden layers. So every hidden layer will try to understand the high level concepts of the input. So layer 1 may understand the edges that are present in the input image, and layer 2 may form these edges and group them into semantic representations such as lines, rectangles and so on. and whereas in layer 3 and 4 and so on, it will create high level understanding of those images. So that's what deep learning, that's what the layers in the deep learning means. So this is the extension of the previous figure, where here you can see the input image representing the digit number 4, and then you have the input layer, and in layer 1 of hidden layer, okay, it tries to understand the edges, and then layer 2 will take the output from layer 1, and then it will form higher level representations, maybe small objects such as lines and so on, and then layer 3, and these outputs from layer 2 are trying to be predicted as high level objects. So here you can see some pixels are dark black and some of them are gray, and here you might see it's something, it looks like number 4 and so on. So finally the output layer will predict the output image for the given input, for example the letter 4. So how deep learning models work? It's a simple architecture. So you are giving input X, which could be image, video or anything, and then the input is represented with so many different layers, and you also need to give you the random weights for your model, okay, and where your model, okay, will predict the output Y dash. Now the predicted output Y dash have to be compared against the predicted actual output Y, and based on the loss functions. Loss functions are error functions which will give you the error value, and that is going to be optimized, and then weights are going to be updated. So the new weight is nothing but the actual previous weight plus the error value, and this is how the training happens for every epoch, and finally, okay, you will end up with the best weights. So the aim of deep learning model is to predict the best weights for the given training data, so that once training is used, then you can use it for predicting new inputs or new samples. And the current achievements of deep learning is anything, right from image classification to speech to text, language translation, that is converting speech of one language such as French to another one like Spanish. And Alexa is a popular digital assistant for speech understanding, and driverless cars and improved search engines, NLP, NLU, okay, understanding natural language questions. There are many applications of deep learning. And why do we need to worry about deep learning? Do we need to learn deep learning right now? Yes. If you look at this chart, you might see the investments in terms of US dollars, billions of US dollars. And investments are growing exponentially by various countries, and US, okay, is a leader with more than 8 billion US dollars, and then China also invests a lot, and European countries and Israel as well, okay, and India also invests some amount on okay, deep learning. In addition to investments, you might see the advanced hardware in terms of GPUs, and data is also, okay, flooding data exponentially, and benchmark data sets are available, and deep learning algorithms are growing, okay, every day. So computation is going to be very easy, and it's something like you just import one model and then predict output, something like your Lego bricks. And not the least, deep learning will last for many years. So definitely it's the right time to learn deep learning. So today I have learned some basic things about deep learning like AI, ML, DL, differences, architecture, and then working, and also the reasons to study deep learning and current achievements of deep learning. Yeah, thank you.